Thank you so much for coming here. I'm Raj. This is Machik. We are co-founders of Prophecy, and we're going to be talking about designing a Copilot for data transformation. So we're going to go pretty quickly through the slides, and then we'll go through demo. Yeah, let's get started. So when we talk about, I guess, the agenda. So first we'll talk about the evolving data needs, just go very quickly through that. The existing solutions, you all know that, but we'll mostly go into the Copilots, like what's the promise, what can they do for you, and how you can design it, how do you get generative AI to work for it, and then we'll spend a bunch of time on demo. So first thing is, who's the Copilot for, right? If I'm a data user, I'm like, okay, GitHub guys got a Copilot for the programmers, right? Where's my Copilot? So this Copilot is designed for data users, especially for them, where we want to enable all the users in the data platform team, the data scientists, and the data analysts in the line of business, enable all of them to process data for all kinds of analysis. And now you have more unstructured data. You have generative AI, that's just putting more load on the teams. A lot of times what we see is that the line of business data analysts are blocked, data platform teams oversubscribe, already doing the previous ETL, right, or data transformation, and now suddenly you have all the generative AI stuff coming. So you have a couple of categories of existing solutions. So there is legacy ETL. This is your Informatica, ab initio, Alteryx, data stage, right? The production ETL, the line of business ETL in Alteryx. And these were easier to use, but built for a different era, don't work well with code, don't scale as much. It's not like you're going to use that with Databricks. On the other side, you have the cloud data platform. So this is your Databricks, other cloud data platforms. They're very powerful, but they're very hard to use, right? It's like only wizards need apply. So as we try to articulate the problem, for us as to what we build, the main three things that we came down to is we want the solution to be intuitive, right? There's not going to be a good data solution unless you can enable a whole bunch of data users, not just a few, but majority of the data users in your organization. The second thing is it's got to be powerful, and this has been a trade-off, right? If you get the visual tools, you don't get all the power of code, you don't get, all the scale. And we're like, no, you got to have that too. And number three, you got to have it to be intelligent. Generative AI has got to come and do half your work. It's like, that's what you want, right? You want generative AI to do half the work. So we've got to have all three, and there's been nothing in the market like that. But Copilots with AI, we live in the age of Copilots, they're going to change the game. So a lot of times, like GitHub Copilot, people have seen up to 55% reduction in time it takes to complete a task. Anecdotally more, it's like 20 to 30%, making programmers more productive. So we can see that applied to programming, generative AI can do amazing stuff. So the data platforms are getting bigger and bigger, right? So like Databricks had Spark, they added SQL, now they got Archeon, they added ingestion. So these things are getting wider and wider and wider, and they're focused on providing you with as much functionality as they can. The metadata catalog's gone there, perhaps data quality will go there, but the platforms are going to provide you with everything. That's a very, very large feature set. But what they're not focused on is users. So you've got to make a product that is for the user, that makes you productive with the systems you already have. So this is about taking as many users as you can, the data engineers, the line of business analysts, the data scientists, making all of them productive on the data platform that you already have, right? Then we set out and had a chat in the company, and we said, okay, if you're designing a Copilot, what are the requirements for a Copilot, right? As I go through them, you should be like, duh, that makes perfect sense, right? So the first thing is it's got to be intuitive. We talked about that. Everybody's got to be able to use it. It's got to be intelligent. Gen A has got to do half the work, so I guess that's not controversial. Next is open and extensible. Unlike the old ETL tools, we don't want people to be locked in. We don't want people to not have the full power of code to extend stuff. So we're like, it's got to be open and extensible. We're done with that lock-in model. And then it's got to be integrated with the systems you already have and help you through the entire life cycle. And it's got to be comprehensive, because what are you going to do now? Get 3 Copilots? You know how those modern data stack companies are like, oh, let me sell you 10 different products. Now you integrate them. So we don't want to get into the integration of Copilot business. So it's got to have, help you with the full data lifecycle. So as we looked at it and said, okay, how do we design these, right? If those are the requirements, what technologies do we need to build a product that will, do well on that? And then these other technologies, let's go through them and see if you guys buy that this solves the problem. So one is visual interface. You have to enable a lot of users, artificial intelligence, obviously, and the third candidate is compilers, because everything has got to work with code, and that's the secret glue that stitches everything together. Now, the first thing, of course, you can't scale if only a certain number of people, very few people in your organization can use the data. So that's got to be the first thing, so that we set out as the first goal. Now, what's the right interface? Some people are like, I like to code, I like Python, I like Scala, that's great. Some people prefer visual drag and drop, and some people are like, I got generative AI. I'm going to write a text prompt, and I want the answer. So as we looked at it, we said there's ease of use, right? Visual text, everybody can write it. Code, maybe fewer people, right? Your data analysts are not going to be able to write it, or do not want to write it, right? And it's just more productive to have visual interface. Second thing is standardization. Now, this is something that is lesser talked about in the industry. You can code everything, but now everybody's code is going to look different. And then what we see is you're going to come back after 2 years, and you're going to be like, oh, somebody else wrote this code. That person's long gone. We don't understand any of this. Now there's this big blob. The people who wrote it are gone, right? So for change management in the organization, yes, code has all the power, but it's not very standardized. So for standardization, visual is pretty, like you're building, if you have high quality Lego blocks and you're stitching them together, very standardized pipelines can be built, and the new person can just come in and understand them, right? Hit play, you see data after every step, you're like, yeah, I understand what's going on. And then there's precision. Of course, text cannot be completely precise, right? It's like if I just had to build 100% of the pipeline using text, I'd have to talk to my pipeline like 20 times, because not to make small changes. And then finally is extensions. You need code. You're not going to be writing extensions to your platform in English, right? So we looked at it and said, okay, this is how these, how we see the interfaces, right? The primary ones got to be visual. This is where all the data users meet. Everybody can understand it. So visual is the primary interface. Text is an accelerator. Yeah, I can say something in English. It maybe builds a visual pipeline for me. That's great. That's more productivity, but that can't be the only interface. And finally, if you're writing plugins, you've got to code, right? So that might be your data engineering team, and so on. And perhaps some people like to write SQL, and that's fine as well. So in terms of the interface, we got the visual drag and drop interface. And if you click on the top, there's a visual to code toggle. You can see the code underneath. And on top of the visual interface, you can see generative AI, right? And you have different users who are comfortable with the interfaces. We're like, okay, this is everybody getting the interface they already have. And Mach is going to show a demo of that. So if some of it's not clear, don't worry too much about it. The second thing is data pipelines take too long to build. You want to get to the analytics. You want to get to building new generative AI stuff. Who wants to build pipelines of moving tables, right? You want to do it quickly. So more productivity for every team member. Generative AI has got to do half the work for you. So it'll make recommendations even when you don't ask it to. It's your Copilot, right? It's gonna complete your pipelines. Maybe you ask something in English, it's gonna write that for you. Who wants to write tests? I've been a developer very long, don't like to write tests one bit, right? So generative AI, make it write tests, make it write documentation, right? Documentation is just you repeating what you did in code, right? So that should do half your work. Now, and then now with AI, I'm going to dive a little bit deeper and say, what about the specific technology and how to make it work, right? So what we do is that if we have to make the visual interface and generative AI work together, the generative AI, first you have to have context, right? If you use GitHub Copilot and you're building a data pipeline, it knows nothing about your tables, the schemas, how they connect to one another, what values you've already computed from that. So we take the code, we get lineage, we build a knowledge graph, and what's happening is that whether you write a prompt or we auto-trigger it, we are taking that knowledge graph and combining that knowledge about your context with the prompt and sending it to LLM. So the prompt engineering is automatic, it's built in, we'll show it. I mean, you'll never not see it, but it'll just work. The next thing is, you have a large language model. It's trained on code. Nobody trains large language model on a visual pipeline because this is just not like English and visual pipeline stuff out there. So you want that full power. So when you give an AI a prompt, it's going to give you a blob of code. What are you going to do with that? Especially if you got a data analyst who's like, let me quickly build some pipelines. You got an ETL developer, but even if you knew code, like who wants to deal with it every time I got a blob of code? First I understand it, then I modify it. That's painful, that's not productive. So as the code comes back, so AI will give you code back, but what we do with compilers is correct the code. If there's any errors, we guarantee that any code that comes back will always work. Now, it might not do 100% of what you want. Maybe it does 80%, but you can make a few last mile changes, right? And then we restructure it, break it up into bite-sized pieces. That comes back to you as a visual pipeline. And now you can just hit play, see again data after every step. You understand what has been done in 2 minutes. You quickly go in, make some last mile edits, and you're good to go. So then, as we looked and said, now we go one level deeper and say, but what about the models, generative AI models? What do we need from that, right? So we have 2 basic categories, right? There's promptless AI. Promptless AI is, you don't even say something. Let's say you write a column name, a target column name, and you hit tab and you're going to write the expression, and in under a second, an expression shows up and said, I think you're gonna write this, right? You can accept it, reject it, but something like that, you shouldn't have to write a prompt in English, right? It's not like if LLMs are English, you have to keep writing prompts, right? So that is promptless AI. It's got to be really fast because you didn't ask for it. In less than a second, we'll suggest something. You want to use it, use it. Don't want to use it, just overwrite it. It's non-intrusive. And then there's the prompt AI, right? Now I asked for something. I really need help. I'm going to write a prompt. Think about it. Give me high quality stuff back. Right, so that's the other model. Here we want higher quality of the models. You want to build a full pipeline from English, or you have a pipeline with 60 components and you want a 3-line summary of it that describes the intent of the user. So in terms of model selection, we looked at Llama 3, 8 GB, something a smaller model, very fast, good for promptless AI. You look at Llama 70 billion parameters, much more accurate. So if you want to have larger scope, you use something like that. Of course, there's the OpenAI AI equivalents of that, but those are 2 models. It also has to work with your privacy model, right? So some of our customers are like, I'm not going to use OpenAI. Some customers are, I have a private enterprise account, so that's fine. If some customers are like, deploy in my VPC, and I don't want to send data anywhere, it's like, okay, you're going to get an open source model in your VPC helping you. So, and the final thing is, don't get locked in or boxed in, right? Nobody wants to get locked into another solution. At least we don't like that. So compilers bring full power of code. You build a visual pipeline, you're going to get code. AI is going to give you code that becomes a visual pipeline. And then finally, we have extensibility. You can write your own standards and frameworks using standard Spark code or SQL code in Prophecy and bring that to all the visual users. And so Prophecy Copilot, making all your data users productive on the data platforms they already have without getting one more system of record. And finally, it's going to run across all your data platforms, right? You have observability, you have development, you have deployment. You don't want one more system of observability that's going to do observability across the other platforms. So it's like, you don't want that. You already have systems with observability. You want, that's pretty much it. So intuitive and intelligent, open and extensible, and integrated and comprehensive. It's going to work with your system for the full life cycle. I'm going very fast because I'm out of time. So Maciek, with that, all yours for the demo.
Yeah, cool. Let's do some exciting stuff. Hope you guys can hear me well and see the screen as well. Yep. Okay. So Raj was talking a lot about how to build a data transformation copilot. We're going to show you how one works in action and how does it work in Prophecy. So let me just exit out of this. Okay. So when showing all of this stuff, I'm going to focus on an actual example of me pretending to be a data engineer, trying to deliver reports to my CEO sitting right here. I will start with half work done by one of my engineers. So one of the engineers came in, they built a little bit of code on my Git, and I have this project right here. It actually has a lot of stuff in it. It is acquiring data from Amazon, Google Ads, and LinkedIn But what I really need to deliver to my CEO is not a raw data, but a really nice, pretty report on the other side. So that's what I'm going to try to drive towards. Unfortunately, this report, as you can see, almost has nothing, and it just uses some LinkedIn raw data. So what I can now do is use the power of data transformation Copilot to deliver on all of this work much, much faster, since the deadline is in just a few hours, or really by the end of this session. So I'll go ahead and start on the prophecy canvas. Hope you guys can all see it really well. And I'll just start by bringing in all of the code that was written directly in SQL into prophecy. So I'll just hit on import an existing project and connect to my Git. I'll pick the right repository. This is my analytics dice project. And set it up right here. In this case, this is a SQL project, but Copilots work on any language, right? So if I want to write it on Python or Scala, I can do that as well. And everything is going to be running on high-performance Databricks compute on the other side. Perfect, so I have my project. Before we were looking at code, as Raj was mentioning, in Prophecy, everything actually starts with the visual interface first, looking at the lineage. So now I can see all the bad work that one of my engineers did. It's a little bit of a messed up project, actually. There is some sources right here. There is my report that they are trying to drive towards, my account report, but all the other sources are not connected. Lots of work to get done. There is lots of warnings and errors to fix. So let's go ahead and start working on that. Prophecy and our data transformation Copilot is all based on Git, right? So we're going to be building out a new branch that I'm going to be working on. This is my 6th attempt at this. Let's see if this is going to work. There we go. So we have our now branch spin up, and let's start working on it. One of the very first things I need to fix is our Google account reporting, right? So we have 3 different account reports, and then we need to all merge them together. I'll start with Google. It's absolutely empty. There is nothing here, but I do have a bunch of sources available. So I'm going to choose my very first source. It's going to be account history, and just add it directly in. And now I can see the Copilot already starting to do some work for me. So at the very bottom left, I see all the other sources I can join this model with. And I can see that I can join it with this account statistics table. I can just press on that. And I have that join automatically created for me. So the Copilot does things for me as I keep going and developing my pipeline. At any point, I can run this. This is actually going to run, compile, and execute on Databricks. And I can, of course, look at what the logic was created. And so I can see that join condition right here and a clean set of expressions. I can deep dive into the data. Perfect. I have 3.5 million different data points from Google Analytics and all of the data preview right here. OK, this is good, but my reports need to summarize data per each account, right? So I'm going to now click on that plus icon and start interacting with the English interface. My data, if you noticed before, has those spend, impressions, and cost columns. So I'm going to aggregate them for every single profile. Let's go ahead and do exactly that. So some costs, impressions, and spend for each account. Hit enter, and the Copilot automatically understands your schemas, your tables, all of the code that has been written out previously, and just develops the right component for you. Here we go, the aggregate appeared. I can open it up, and it's a small component, but it does exactly what we asked it to do. We have all the right expressions here and the group bys. If I want to keep interacting with it visually, I can as well, right? I can just start modifying it and adding remaining columns into it. So it's really, really easy. Whether I want to use the Copilot English interface, the visual interface, all comes along in one. And I can now run it and start seeing again the data showing up after my aggregation. The very last thing that I would like to do is that some of my spend is not really neatly formatted. So let me try to clean this up. I can drag and drop one more component. It's a reformat. It's essentially like a data transformation. Let's add all of my columns, and let's add a new column that formats my spend. As I type the column name, now again, I can see Copilot already doing stuff for me. So I now can see that a transformation predicted right here. which is good, but it's a fairly small transformation. I actually want to enhance it a little bit better, and I want to add currency codes to it because we already have a currency code column. So let me just write that down directly with currency symbol. Hit enter, and wow, so now I can see that the Copilot actually understood my data. It knew which currency codes are available and merged that directly with the text for me, right? So for my American customers, I can see the dollar amount. For the customers located in United Kingdom, in pounds. Perfect. And this exactly reflects the data that I was looking at before, right? So we have all those currency codes available. The Copilot understood what data is out there and wrote the expression that exactly works on those currency codes. Awesome. So with all of that, now I have this one first pipeline completed. We're 5 minutes in, lots more work to be done. Everything that we've been doing so far developed high quality code on the other side on Git, right? So this is in this case SQL, but remember Python, Scala, Airflow actually is supported as well. Visual is awesome. There's gonna be some people that are gonna come in and say, hey, well, no, we want to code. We don't like the visual view. No problem, so let's now build a new model, this time for Amazon, that's going to be built out completely out of the code interface. Remember, our Copilot works both on the visual, so that it's easy for you to see immediately what's happening within your project, and then code for those of you who know how to write SQL code. My Amazon model is going to use 3 different sources: campaign history, level report, and profile. So let's just start writing that. This is a standard DBT-like format, so some of you might be already familiar with it, and I can start typing this code. So I'm going to create the first source with campaign history, and I can already start seeing that the Copilot is now also working within the code interface and predicting the next lines of code for me. So this is perfect. This is my very first source. I'm going to add profile data as well. Awesome. And report. So those are just sources. This is pretty easy so far. Let's now join them all together. So this is going to be my report history profile. And we have now the join code created for us here as well. It does performs 2 different joins on all of the 3 tables. Okay, cool. Now remember, it all cooperates and works at the same time with both the visual and the code interface. So I can jump back to the visual interface, and everything that we've done so far on code is represented to me as visual. If I want to open it up, modify how it works on the other side, I can, again, interacting directly with the visual. So let me, from this visual side now, pass through a few columns. This is much easier than writing it out in code, so I'm just going to do it right here. There's a few columns that I care about, some from my reporting, some more from my profile information. So let me just pick them right here. Okay, and then the most important columns, the actual spend and impressions made by all of those profiles. So 3 simple columns right here. Okay, nice. And now I can go back to my code, and again, I see that code generated for me in real time as well, with all the comments and documentation as well as I go. I can keep on working on this code if I'd like to. Let's aggregate this data. So I'm just going to sum now all the costs, clicks, and impressions. And again, I see the Copilot just writing out that code automatically for me. In this case, it actually did a little bit too much, but no problem. I can just fix it up right here. It did sum up all the amounts exactly as I wanted, but I do need some extra fields. So let me add them right here, and let me propagate some additional fields too. I'm going to start out by writing some fields that should be propagated manually, but then as I'm writing them, the Copilot now starts seeing what I was doing and knows immediately the next step that I want to do, right? So I propagated source relation. Now it knows I want account name, account ID, currency codes, and the last column as well, date day. Perfect. And I can just finish up my model directly by querying my sum of all the costs and clicks and impressions for every single profile. And there we go. We wrote the pipeline directly in code. We had the Copilot writing some of it for us because it understands what we're trying to get done. And now we are seeing that pipeline represented back in the visual canvas. How easy and fast this is now. Okay, so we have Amazon, we have Google, great. I am seeing though that for Google, we have one more additional source that we need to map. So this is one of our earlier stages, one of our bronze layers. And I actually have here already a model developed for me of how the table should look like. So I have the right schema, I have the right descriptions. Maybe some users are already writing to this, but I need to onboard a new source for it. So again, let me just drag and drop this particular source right here. So this is my Google ad history. And normally what I would have to do is I would have to start writing all of the mappings for every single columns line by myself. The data that I'm working here is actually a little bit more complex because from my Google, what I'm expecting is a parsing of URLs and extraction of UTM codes. So a little bit more complex logic. But now Copilot can start predicting some of this stuff for me. So I can open up the reformat component, and wow, I can see all of the expressions automatically now written out for me. For every single column that we were trying to map to on the output, and every single input column, we now see the appropriate expressions. And it all works on a local model, so it's very, very fast as well. And if I want to modify it, again, I can just keep on reworking any of this. And I can use Copilot for it, or I can just write down some of those manually. Okay, cool. So with that, now we have all of the two models developed, schema mapping created. We can look at our lineage very quickly and see where we are with our progress. So we have now our Amazon account report ready, Google account report ready, LinkedIn one ready, but now all of them have to feed to our final all account report that contains and merges all of this data together. So what I can do is I can go up into this all account report, and normally I can start dragging and dropping, but I can also use the chat interface to directly just tell it what I want to get done next. So in this case, I need to add all the other sources that I'm working with. So I'm just going to union directly with all the other account reports. Copilot knows which account report I'm using, which account report I'm building, what are the ones that I've just created, and automatically adds that definition of the rest of the sources for me, unioning them and creating that final account report. How much time am I saving now building this stuff out? Isn't that cool? With that, I can also keep interacting with the Copilot further. So for instance, here, I get account IDs. Maybe I want a little bit more demographic information so my CEO know exactly which users to chase. So I can just add that directly in as well. Propagate account names. And it will just add from every single one of the source, select the account name column, and add it back up into my target model. There we go. If I open up my union, I see all of the 3 different sources aggregated together and a single model created on the other side. Okay? And just like that, all this work, we've built out multiple different models, mapped multiple different sources, created our final report in just 15 minutes. Very, very fast. It wouldn't be possible with the data transformation Copilot. With that, we can also now start scheduling it. My CEO doesn't want it just one time, he wants it on a recurring basis. So here's my schedule that we've created. It's already an existing Airflow schedule that's running on a weekly basis. It's pulling the data from S3, executing all of my code directly on Git, throwing it up at Tableau, and then notifying our users that the dashboard has been updated. All of that was, of course, built out visually, very easy to configure any one of those gems. On the other side, just saved as high-performance Airflow, in this case, code on Git. And now I can start productionizing my code. I have all of my modeling logic, I have all my scheduling logic. I can just press on commit and go through this whole software engineering best practices cycle, but on an easy-to-use interface. Copilot, again, does stuff for me, including writing the commit messages, writing the descriptions for my pipeline, and release notes. And I can already see that it did write a commit message right here for me. Okay? Cool. So with that, now we've productionized our project. There is one last small thing that I would like to share with you all. Very often, we see people coming from other legacy products, right? Products like Informatica's, Alteryx's, Data Stages, sometimes also from the other code bases. And they're trying to transform them, modernize them, and run on modern infrastructure like Databricks. Here is actually one of those projects that you can see directly here. This is Alteryx right here running in a Windows VM, because that's unfortunately what it requires. But it transforms all of my data, merges it together into a single source. This is a little bit more of a healthcare use case for intervention preparation. It's a fairly complex and large pipeline, though. It runs directly on Alteryx. It takes 7 hours to run on a single desktop Alteryx machine. You can't scale it on that. Now what I can do with Prophecy is I can start bringing some of this legacy code directly using our Copilot data transformation into high-performance Spark code with the product on top. So I'll just go ahead and start the import process. We support a bunch of different tools, but in this case it will be Alteryx. And I'll just import the pipeline right here. I can import it to any language. As I mentioned, Spark, Scala, SQL, all of them really well supported. I'll just stick to Scala for now and select the Git project that I'm importing it to with appropriate branch and Databricks connectivity as well. I'll choose that YXMD file, which is that Alteryx extension, and decide on some additional configurations. With that, I can hit transpile, and the data transformation Copilot automatically goes component by component through this Alteryx pipeline and converts it for you. Even though that pipeline might have looked massive on Alteryx, it's actually fairly small in the hindsight of probably some of you having thousands of them within your organization. So it ran pretty fast. I can import it directly, and I'll be able to see all of the pipelines and data sets that I'm going to be creating. So let's go ahead and hit that import. I can see perfect, 100% of the pipeline got converted, and I can actually see how it looks like right now in Prophecy, backed by that Scala code that I have decided to create. And there we go, we have the exact same pipeline. It looks visually very similar, almost the same to that Alteryx one that I've seen. It's still a tremendous amount of different transformation logics and sources and components that are driving towards a single target, but now in a snap of the fingers, converted directly into Spark Scala performant code. If I start running this on Databricks, which I don't think we have enough time for, this will be running for 4 minutes now, instead of the 7 hours that it took directly on that Alteryx single compute machine. So much, much faster, all thanks to the power and scale of Spark under the hood. And and so that's it. So that's the data transformation Copilot, making everyone very productive on any interface they want with AI, and very easy journey to start using it.
Yeah, I think we should clear up the room. I'm so happy to have a chat outside. Thank you so much, everybody.
Thank you.